deep submarine underneath deep blue sea. Saw the flag, Japanese. What's up? My name's Ryan, and I'm a junior at Virginia Tech, and I made this video to teach a little bit about petroleum and all the intricacies of it. Sure, if you've been around geology, you kind of know that, petroleum is made from organic decaying matter, and the carbon base from these plants is there from the energy created from photosynthesis from past eons, and that kind of gives us the power that we have. Most of the oil is found in layers deposited from the Mesozoic era, which is an era, and a lot of the fuel we use now is made from petroleum. For example, oil and natural gas are made from petroleum or crude oil, and these are kind of the ones that we're going to be looking at in depth today. Pretty much whatever I think was interesting, whatever I think could be cool and hold your attention, I guess. So gasoline, when used, releases the carbon stored in it, just like natural gas, but on the plus side, natural gas is mostly methane. So, and this contains a lot less carbon in this gas than gasoline does. So natural gas is a cleaner form of this fossil fuel because it releases the least amount of that carbon. And obviously, when it's found in the ground, it's crude oil, it's not in its end state, and it takes a couple of steps from pulling it out of the ground before we can put it into our car. Yeah, so when you find it in the ground, it's called crude oil, and you make everything from diesel to gasoline to tar to lighter fluid. And here's kind of like in this picture, just kind of an example of, like the heavier, super clean and stuff like that, just kind of different forms of the oil and distillation and stuff like that. So to refine crude oil, you have to heat it. And when heating it, an interesting thing happens, and it kind of breaks down the hydrocarbons, which is the building block of this crude oil, are broken down into different forms, which then we separate through distillation. So distillation is a super cool process. I don't have any experience distilling gasoline, obviously, because who has a barrel of crude oil in their backyard to distill it? But when I was in high school, me and my friend made alcohol for a project. And I know you're like, oh, did you drink it? Actually, it was a really cool project. So we were trying to test to see if sweet potatoes or regular potatoes made, which one produced more alcoholic content based off of their sugar and the yeast. But anyway, so in order to get the alcohol out of the water, what we did is we had to boil it around I think it was 200 degrees Fahrenheit, or 190 to 200. Just below that boiling point of water, because alcohol boils at a lower point than water. So the alcohol will turn into gas, and then we could collect it and just kind of funnel it through these water containers, which cooled it down and gave us this liquid. And that's basically kind of what they're doing with this oil. They kind of burn it at 35 degrees Celsius, and just kind of so the gas, the butane and the really light gas fuels, and just kind of continually doing that until they kind of get all of it out, and all you have left is the stuff they use for asphalt. So finding petroleum, another cool thing I had in geology last semester, had this lab where we pretended to be CEOs looking for oil and our next kind of oil source. And it was really fun. It taught me a lot about looking at different seismic graphs and to see a little bit about what it looks like underground and kind of how they see it. So there's 4 conditions to form oil, and when you're looking for oil, you're kind of looking for these conditions. You've got a source rock, a reservoir rock, an impervious seal, and an oil trap. If you look in these pictures, you kind of see different aspects of just kind of so you have up here, and just kind of how the oil is kind of trapped in there, and this is like a dome seal, and this is so you have just these kind of different seals and how it traps in here. Oops. And yeah, so basically the most important thing is you don't want oxygen in there, because the oxygen kind of helps the oil and stuff in the plant bases inside of that decay faster. And that's really what kind of transforms it with the pressure. And yeah, so a seismic graph kind of looks exactly like these pictures, except it's in black and white. So you can't see, oh, this is black, this is oil, duh. But basically you just kind of look for these shapes and the right traps. And even if the shape's right, it doesn't necessarily mean there'll be oil. It could just be water. But actually, interesting fact, all kind of, I guess, oil fields have water in them. And this is called oil field brine. So when you're pumping it up, it's just going to kind of like, you have to kind of separate the oil field brine from the oil. And the oil field brine is just really salty water, which no one wants because who likes salty water? Not people by the ocean. So, but like, I guess, like, want to break it down a little bit more. Like, how does oil actually form? Or, sorry, like plants and oil. And so you have the, like normally you're like have a delta or something where it comes over, it covers all the plants and like kind of takes the oxygen away really quickly. And that's kind of how the plants turn into oil. But how do the plants get the energy to do that? And I figured that would be an interesting thing to step back into. So there's 4 conditions needed to apply, obviously, after it. And then the sunlight kind of converts into plants, which converts carbon dioxide and water, and just kind of is that catalyst which turns into sugar and oxygen, and ultimately energy. And then the plant, which is burned quickly, converts into oil. So, I think I just want to shout out to Melvin Calvin for creating the Calvin cycle. And just really just kind of expanding this form of just our understanding of photosynthesis and helping us understand a little bit more how oil is created and all that. So this is kind of another form of oil. We've talked about oil and the crude oil and stuff, and this is just like the next form of that. And it's called oil shale. An oil shale is generally mudstones that yield petroleum when burned. Basically, kind of the same as like regular oil. It's the lack of oxygen that kind of produces this. Unfortunately, unlike the other oil, it's really expensive to turn this mudstone, shale, whatever you want to call it, tar stone, into something usable. The cost of extracting it is just much greater than you could ever get from it. And generally, the oil shales are made from swamps where you just don't have a lot of oxygen. Plants kind of get stuck down there and then they turn into the oil shale. So while I was kind of researching oil shale and looking at all of that, I came across something honestly really interesting. So generally, when I look at just kind of U.S. oil production versus like Saudi Arabia, you're like, oh, well, Saudi Arabia is so much bigger. They have like 10 times as much oil reserves. And then you look at Venezuela, Russia, Iran, all of them kind of dwarf us as far as oil reserves. But then I came across this statistic or stat or whatever where we have like 2,000 billion barrels of oil in oil shale. And obviously, like, there's not kind of a lot of, it's not really usable right now just because of the economic cost. But I think it's encouraging that, like, okay, we're not almost out of oil. Like, there's a lot of stuff there that could help us, get further into harnessing like lights energy and stuff like that better. So, if you want to be the next, billionaire or whatever, kind of figure out how to take oil share and make it so we can make a good profit off of that. And then, we'll definitely be like a leader in the production. I mean, even if we could get half of the oil out of the oil share, that's still an enormous amount more than everyone else. So I guess kind of the last topic I wanted to talk about, because, I didn't really talk a ton about natural gas, is just kind of fracking. And I know a lot of people kind of think negatively about it. And basically in this method, people kind of drill a hole down and then like pump water with other chemicals into like, see these like veins like around in here, kind of like the gas and stuff gets stuck in these. And just kind of the idea is just kind of encourage the permeability so that the gas will come out, just so that people can just, we can get the gas and use it, because natural gas is not only like cleaner, but there's lots of uses for it other than gasoline. So this production is really a huge industry. But definitely some of the side effects, and obviously there's side effects for oil too, like where ships spill oil and oil spills and stuff like that, and then the carbon footprint from the burning the gasoline too. So we're not minimizing those, but fracking has definitely come under fire because of just I guess in Oklahoma, there's like the extra earthquake potential where they're like, I think like taking all the stuff out of the ground kind of makes the ground more like shakeable and like firm. I don't know whatever the word is, but it makes it, and like the earthquakes out there are getting worse, and they're kind of trying to correlate that between hydraulic fracking and these extra strength earthquakes. But one thing we do know is that there is ground contamination, and the like chemicals that they release in there, they're only getting back maybe 90% of them. So there's definitely leftover stuff contaminating the ground, contaminating some of the water source, and then these chemicals, they're not even collecting all of them. So those are also pollution. And then the air pollution, like from those chemicals that are released into the air and stuff like that. So yeah, that's my project, and I hope you enjoyed it, and I hope you enjoyed a little bit of Lumineers. I love them, and yeah, I hope you have a great day.